Hi folks, we're going to take a look at number 1 from the intersections of lines and curves sheet. The first question asks us to determine the point or points of intersection, if any, between the line y equals 2x plus 7 and the parabola y equals x squared minus 4. Okay, so before we start this particular question, let's just consider the idea of intersecting a parabola and a line. So say we have some parabola. Let's think about what the possible scenarios are. So one scenario is that a line could cross through and intersect at 2 points. So we have 2 answers. Another possibility is that the line never crosses the parabola, so it lies completely below the parabola, say, in this case. Another example is if the line touches the parabola just at one single point, what we call being tangent to the parabola. Okay? So essentially we have the scenario of 2 solutions, 1 solution, or no solution. Now we've seen this before. We've seen it in the case of quadratic equations, have the exact same scenarios available to them. So it stands to reason that to solve this problem, I may come down to solving a quadratic equation. So I kind of have a sense of this before I even try to solve it. So let's go ahead and look at this particular example. Now, when we were solving the intersection of 2 lines, we did that analytically by solving a system of equations. And here we see that we have a system of equations, 2 equations with 2 unknowns. The difference here being one of the equations is not linear, which we've actually seen this scenario before when we were solving some measurement problems. Okay, so we can see if we can solve this in the same way. So let's see if we can use elimination. Now that does look promising because I have a y on its own in both of the equations. So if I consider option number 1, which is elimination, so we take the 2 equations and we add or subtract them, hoping to eliminate one of the variables. Okay, so here we see that if we subtract the equations, the y's will subtract to 0. So if we subtract the 2 equations, y minus y is 0, so we end up with 0 on the left-hand side. And if I subtract the right-hand side, so I have x squared minus, well, there's no other x squared, so it'll remain x squared. Here I've got no x's, but I'm subtracting 2x, so minus 2x, and then negative 4 minus 7 is negative 11. Okay, so look what I end up with, a quadratic equation to solve, exactly as we anticipated. Now the other option is substitution. Let's see if we can manage to use substitution. Okay, well, substitution works on isolating one variable and then inputting it into the other equation. Well, here, let's say the y is already isolated as 2x plus 7. So in the other equation, wherever I see a y, I can just replace it by 2x plus 7. So if I take this equation, replace y by 2x plus 7, and that's equal to x squared minus 4, and look what we have, a quadratic equation. So if we put it in the form that's required in order to be able to solve it with the quadratic formula, or factoring. In other words, we need 0 on one side of the equation. So here, we'll leave that there, x squared. The 2x, the other side, becomes minus 2x, and then negative 4 minus 7 minus 11. I end up with that same quadratic equation. So we see here that both elimination and substitution work equally well. Okay, at this point here, though, let's solve this equation now, at least for the x values of the points of intersection. Clearly, factoring is not going to work with 11 as our c value, or negative 11. So we'll use the quadratic formula. So x is equal to, so negative b, so the negative of negative 2 is positive 2, plus or minus, okay, here we have b squared, so negative 2 squared minus 4 times a, which is 1, times c, which is negative 11, all over 2 times a, so 2. And so this looks like it will end up being positive, so we should have 2 solutions. But let's calculate that input to the square root. So we've got negative 2 squared, which is just 4, minus 4 times negative 11 gives us 48. So 2 plus or minus the square root of 48 divided by 2. Now in this question here, even though it's a straightforward math question, I am asking it around to 2 decimal places. So normally, if it was exact answers I was looking for, I would expect you to simplify this square root, not to leave it as root 48. But here, we're trying to approximate. So here, let's find our two approximations. So first we have 2 plus the square root of 48. Now, since I didn't put brackets around this expression, I have to actually calculate the numerator first. Okay, and now I can divide by 2. So here we have 4.46. Okay, or we have 2 minus the square root of 48 equals, and then we divide that by 2, and we end up with negative 2.46. Okay, so we end up with 2 values for x, so that means we should expect 2 points of intersection. Okay, but since we're looking for the points of intersection, we need to find the y values. So remember, this point is on both of these graphs, so I only need to use one of them to find the y value. So let's say I've used the linear one, so I'll call this A, I'll call this B. So YA is equal to 2 times 4.46 plus 7. Okay, let's calculate that. So that's 2 times 4.46 plus 7. Okay, so 15.92. And then the second y value will be 2 times negative 2.46 plus 7. So let's calculate that. 2 times negative 2.46 plus 7 gives us 2.08. Right? So that means that our points of intersection, okay, are 4.46 and 15.92. And then the second point is going to be negative 2.46 and y value 2.08. Okay, and what I'll do here is, as I suggested, checking with Desmos. And so I've got Desmos here ready to go. No, actually, here's Desmos there. Okay, so here we have the parabola and the line, and if we look for the point of intersection, we see negative 2.46 and 2.07. Well, we were close, 2.08. I guess it had to do with our approximation. And here, 4.64 and 15.92. Okay, so we got the correct answers there. Okay, so again, we see that even when we have a system of equations when they're not both linear, we still can use elimination and or substitution. In this case here, we were able to use both.